System. Again, what I want to do here is kind of walk you through the building blocks of what the operating system is based on, how we do the adaptive cloud fabric, the capabilities within that, then spend a little bit of time on the analytics and talk about what we're doing there, and then we'll go more and more technical and we'll look at the VMware environment and some proof points. I thought it made sense to really give you a sense at a snapshot level of the key things that differentiate us, right? You certainly have no question. You talk to a lot of networking vendors, you see a lot of networking products. What makes Pluribus different? At the end of the day, we're providing a network operating system, and there are a number of companies that are doing that. We don't really focus on the notion, and you don't see SDN plastered all over our slides. We've kind of backed off of that notion of SDN because a lot of people tell me they still don't know what it really means and how does that tie into a basic operating system versus a fabric. So really we're looking in a much broader sense. We're providing a fabric-based architecture and a cloud-like architecture. I'll explain that. But the key areas that really differentiate us is, number one, we're a software-based environment. Software-driven, software company. It's all about open networking hardware. Whatever the customer wants to deploy on, that's the goal. It's not about the legacy closed systems in which the customer has to buy certain hardware devices, right? Focused on that open networking environment and the next generation of networking architectures. I mentioned the word SDN, and the first thing that comes to mind is, okay, so how do you scale? How do you build an SDN network to be able to support these environments? And the next thing that comes to mind are things like OpenFlow and controllers. We've built a completely distributed, multi-node, multi-device fabric with no controller and no specialized protocols. I'll drill into that environment. So we scale across geographical boundaries with no special protocol requirements and no controller latency or convergence issues to be able to build that network environment. Everything, and to me, it's somewhat table stakes. So on one hand, I feel if I don't say it, then you think we're missing it. But if I do say it, it sounds like everyone else. Everything is automated. Everything is programmable. From the network on up, we're able to provide the complete automation. And we're going to go into that in how we're delivering automation and scaling that out, not just within our environment, but into the VMware environment itself. And I mentioned several times the fact that we don't need special protocols. Everything that we're going to talk about is standards-based, standard protocols. There's nothing new that you need to introduce into the network. Unless your network is stuck in the 80s and you're not using VXLAN or the latest technologies, you're not going to have to deploy anything special or anything new to do that. And that allows us to deliver a completely non-disruptive network environment. We can insert and interoperate with existing platforms and existing products. And I've mentioned a couple of times the visibility, and we'll talk about how we're delivering and redefining the whole notion of pervasive visibility. So that as kind of the entry, those are the key points that I'm going to talk about and kind of drill down and give you the proof points for. What we announced at the end of April, we really, again, the company's been around since 2010. We've really evolved and matured our technology. If you followed Pluribus Networks and you looked at the company a couple of years ago, you would have heard about the virtualization-centric fabric, VCF. And really, that has evolved from a feature function perspective, and we looked at how customers were deploying it and the problems that we were solving, and we saw really the much more appropriate way to really define what we delivered is an adaptive cloud fabric. Right? And the goal there is to deliver something that's simple. And that's the overarching part of our strategy, simplicity. Of course, networks are complicated, and what we build in the networks require a tremendous amount of effort to make them run. That's why there's network people to do this. There's no question there. But the complexity of adding in new protocols and changing the network environment and dealing with brownfield versus greenfield deployments, we want it to be simple. Simple is the key focus in how we've built this architecture. We want it to be dynamic. That adaptiveness, the dynamism of being able to support new services, new functionality, and creating an environment that's cloud-like, that's going to provide the elasticity and the scale to be able to not only deal with the services that you need at the enterprise level, but being able to, if you're a cloud operator, to be able to provide those services, including tenantization, for their operating environments. And lastly, secure, right? It's got to be a secure environment, and that security has many, many different layers. Unfortunately, today we only have so much time to talk about it. So at the basic network level, we'll talk about the security capabilities, but adding in a broader range of security features, being able to do security insertion and other types of advanced security service integration is also part of the fabric architecture and what we do. So let's look at the architectural stack and how we actually build our operating system on top of an open networking platform. So we'll start with the basis of an open networking box, right? Everyone should have that notion of white box, bright box, open networking. It's basically a hardware platform that ships with nothing on it, right? Companies like EdgeCore, Dell EMC, D-Link, these are companies that deliver products that you can run any kind of software that you want on it. They run a layer called ONI, which is allowing you to then run and boot this operating system on top of it. What Pluribus starts with is with our Netvisor operating system is the fundamental layer 2, layer 3 networking functionality, the OS. It's what we think of when we think of Nexus OS and Catalyst and iOS. It's running the fundamental functions of the box. And what we've built is a best-in-class layer 2, layer 3 foundation. And I say that, it's not just a vendor saying it as a matter of marketing speak. It's from a delivery perspective, how does the product perform? The features and functions, the scale, the reliability, and the ability to deliver the services in an operating environment at performance, right? Performance at scale. That's the fundamental level of our operating system, but this is not what we focus on, meaning there are a number of companies out there that are delivering operating system software on a white box environment, and that's great if that's what the customer needs. What differentiates us are the key points that I've talked about earlier, and that's our ability to create fabrics and to create scale and add services to the network. So building off of that Netvisor operating system is our adaptive cloud fabric architecture. And I'm going to go deeper from a technology perspective and build this out. This is providing the ability to connect the boxes together. So we're all networking, well, not everyone, right? Networking people know the concept of a chassis. It's got line cards in there. Each one of those is a networking entity. What you're doing in a fabric environment is you're taking those line cards that are sitting in the chassis, you're taking them out, and you're connecting them together as if they were in one environment. One aspect of that is managing it, makes it easier to manage as a total entity, but another way is how you deal with the communications and deal with the scale of operating that environment. So by taking the fabric, we're able to build and connect all of these devices together as if they were sitting co-located together. The difference, and I'll go through this through the architecture, I'm going to keep reminding you, the difference is to do that fabric and to create those connections, we don't use a controller. All of that's built into the operating environment. The next level of capabilities within our fabric is intelligence and telemetry. And that's the ability to understand state, policy, and what different endpoints are doing within the network so that we can apply and scale that across the network. More importantly, we have the telemetry. So telemetry is the new age word for what we used to call instrumentation or probes or ways to look at the network to derive performance metrics. And those two key elements are critical when you start thinking about things like intent-based networking, self-healing, self-optimizing, because they work together. The telemetry tells you everything's running, and things like the intelligence, the vPort as we call it, is able to tell you state and allow you to manage those environments. So we've built in across the network telemetry and intelligence at the fabric level so we understand everything that's going on. It's not just basic networking. And the last piece, which I will drill into a little bit more, is our analytics platform or a performance management platform. It's consuming the data from this network environment so we understand how the network is operating, how application services are being delivered, user experience, what the connection states are, throughput, all at the level of from a network perspective. So if we look at this at the operating level, we have the basic operating system that's providing all the advanced layer 2, layer 3 functionality and network services. We add on top of that the fabric capability, intelligence and telemetry, and then application, or I should say network performance monitoring capabilities that look on the stack. So let's look at the operating system. And if you've known Pluribus, this is the one area that I've found many people that I've talked to that have looked at Pluribus in the past weren't aware of. So everyone knows what VMware did for the server, what the whole notion of a hypervisor is, right? We take a basic server, we divide it up, and we put multiple virtual machines that run different applications. The Netvisor operating system does the exact same thing in a network device. This is a very important concept to understand because it's the basis for all of the capabilities that we deliver in advanced security services. We virtualize that switch into discrete virtual devices. So a single hardware box can have multiple personalities. Each one of those personalities can be a tenant. They could be different services. We can do NFV in those functionalities. We can create segmentation for application traffic. And we can create completely different personalities. I could make one part of the switch doing a certain kind of feature like network function, and I can take the other part of the switch and I can do a completely different set of features. So that is at the very basis what Netvisor does. We abstract, right, and disaggregate the hardware and software. So we're sitting on top of that white box. And then we, at the first level, virtualize it. So to give you a little bit of a deeper view on what that means, we call it VNets. And not to, again, go too deep at the technology, a VNet is a fundamental personality, a container from a network perspective that you're able to run tenants, segments, however you want to call it. That VNet, each one of them that you define in the network, has its own control plane, data plane, and management plane elements. We're not talking about VLANs being used to create this segmentation. It's truly virtualized devices sitting in that machine. Each one of them, as you can see, has their own policy. They could be managed differently with different management tools. So this could be a tenant, this could be another tenant, and you're actually able to manage them independently and have no overlap between them. Absolute isolation. We have NFV capabilities with a KVM that we can deploy within each one of those segmented entities. The key thing about this architecture is this gives you the total flexibility to build out any kind of configuration that you want. And so you think, this is great, I can do that on a per switch basis. What we do at a fabric level is we take that entire notion and we scale it across the fabric. So if we build a basic network, and you're going to see a fairly common theme here in all of the slides to get the point through. We don't need to be a bookended leaf and spine architecture. We interoperate with any existing environment. There is no requirement to replace everything. That's one of our significant advantages from a customer perspective. So you'll always see most of the pictures showing us in a mixed network. We can go either way. Right? It can be Cisco, it can be Juniper, it can be whatever the customer already deployed. We just slide in. So building this typical network architecture, but what we do at the fabric level is it is a peer-to-peer distributed fabric. All of these devices understand the configuration of the network across this fabric environment. There is no controller running everything. There's certainly something.
Can I pause you for a second?
Absolutely.
Because I'm having a hard time putting this to a use case or understanding, like, because what I'm hearing is we've got all these different switches. They can all run different instances. They can do all kinds of different cool things on each individual switch, but there's no controller to track it all, which to me is like frightening. So I think I'm probably not understanding. Can you paint for us a picture of a use case? Like where does this fit in the infrastructure? In what ways would we use your switches or your software on switches to solve problems?
So I'll answer the use case and then come back to answer the other question if I could. So there are many use cases, and that's the challenge. This is fundamental networking that you can apply to virtually all of the requirements that you have in the data center and being able to extend that out to other parts of the network, where you need to create interconnected switches that you want to manage as a single entity in a simple operating environment would be the foundation of that.
So without a controller, how do you manage them?
All of that is built into the switches, and the peer-to-peer clustering is allowing the switches to communicate and share state. The state and configuration is maintained in every device on this fabric, and it's sharing that in real time. We've built the controller functionality and distributed it across all of the member devices.
Okay.
If I'm following correctly, like an example would be, instead of having separate networks for maybe backup, and maybe you'd have management for shared services, and you'd have your enterprise data network, you could actually have all of those on top of each other, siloed with one fabric. Control.
Absolutely. And the other would be, take a real customer example. They have 3 data centers, 2 in the US, 1 in Europe. They're running their businesses and they needed them isolated tenant services in the enterprise. No crossover between the BUs. So they're actually running 7 virtualized data centers in 3 locations with our virtualization capabilities, right? And if they move a workload from data center A, say in Detroit, to Germany, they're able to orchestrate moving that workload and the network tenant configurations with it.
So there's got to be some type of database to be able
There
to...
is. The database is shared across the entire member, the connected switches within the member network in the Netvisor environment, right? And there's several databases that we're actually maintaining, right? There's the configuration database, there's the state information. Again, not planned to go deep dive, but we certainly can. There's the vPort, which is the intelligence state database that's maintained across all of these member devices. So we've got all of that happening in the background to be able to populate that. See, the issue with the controller is you're going to come to the controller to program everything. That controller is then going to go and replicate it to all the devices. We come into a device that's going to act as the primary device. It's going to take, and you're managing the entire fabric, which can be global, from that one entry point. It's going to replicate that across the fabric much faster and maintain that state. If that device were to fail, the fabric takes over without losing a beat. I don't have to switch between controllers that fail.
You're still identifying a primary device that is effectively your controller.
Right, but it's identifying that, but all of the knowledge and all of the state is shared across all of the member devices.
It's like a server cluster, right? I mean, that's
This is
how I
based
look at
upon high-performance computing server clustering.
Quote-unquote cluster, a 3-phase commit technology, which if you Google it or Wikipedia it, you can find it on as one of the techniques used in database cluster invented in the 80s by IBM. So it allows the information across this cluster to be kept in effectively in lockstep across the nodes. Now, one point here is you have a single point of management through REST API or command line interface, and any switch is your controller. In a way, if you want to translate it into a traditional SDN thinking, every switch now has the opportunity to equally control as a peer all the other switches in the fabric. And then, of course, also the information and visibility is also shared across all the nodes. But you're absolutely right. The comment on compute cluster is exactly how the technique that's built on top of this layer 2, layer 3 fabric to accomplish this.
So are you doing like some sort of N plus X redundancy as far as distributing this stuff across the cluster? I mean, there's got to be some limit to the number of devices that can fail before you've either lost forwarding table information or configuration information. I mean, this to me seems akin to kind of like Nutanix's CVMs, right, where they're using these distributed databases and sort of a distributed transactional architecture in order to validate that they've achieved some sort of protection level before acknowledging a write back to a host.
Right. So here I think it's important to understand, actually this slide maybe doesn't show completely, but the network is completely distributed. The control plane and the data plane of the network is completely distributed. It means every node it's running its own spanning tree, BGP, OSPF. It's all control and data plane is distributed. Then you have this layer of sort of intelligence or fabric control plane, which sits atop of every switch. And it's also totally distributed. There's no single point of failure in this fabric. So you can have a fabric of 10 switches, 5 can go. You still have 5 switches functioning completely independently. So it's, in the case of Nutanix, I'm not an expert on Nutanix, but the concept of CVM, I think, right? It's sort of the controller for all the data nodes. Here, there's no such thing as a CVM, because every switch, if you allow me the analogy, is a CVM, right? So it's truly fully distributed.
Every switch has complete knowledge of state of the entire fabric.
Exactly.
So how does that, how big can you get before every switch can't hold all that data?
Yeah.
So far, we haven't hit a scaling point in which we can't continue to extend
and what's
that.
so far? Like, what's your biggest totals?
Yeah, so it's about 40 nodes, right? Today you can be 40. It can be, we've tested in a real environment. I can say 400, but we haven't deployed the 400
Yeah, that's fair.
No, but also the other important thing is the following, right? So you can build a 40-node network and manage it as a single logical entity. But you can actually have another 40-node network. In the end, underneath, they are connected through BGP, VXLAN. The connectivity is just a management domain, if you will. We do a little bit more than management. Is a control plane for intelligent forwarding. We're going to peel the onion later. But fundamentally, it's not a limitation of how big or scale out can be your fabric, right? Because you can build pods of 40 and then stitch them together to get to whatever scale you want. I think we can go way beyond 40, but I want to be realistic. We've deployed a 40-node network as a single logical fabric. Beyond that, customer broke it into, because they were in themselves not very comfortable with a single gigantic domain, right?
So they broke it into multiple domains.
But it's not that we are running out of, we're not running out of memory or anything like that at this point.
And we have other techniques, again, just it's the issue of time here, other ways in which we can, I don't want to confuse this and then say, oh, aha, that's a controller, but we can offload some of that management and some of that processing into the compute side to run in a VM that can provide that, but it's still not a controller, right? Because the controller is managing everything. If you look at other architecture that's controller-based, everything is converging and reconverging through that controller. We have no reconvergence.
We can move processes off box, what you're saying.
Correct. Yeah, we take the Netvisor management function and we can put that in a VMware.
I mean, certainly there are some products out there that have a controller that has both the control and forwarding plane in it, but not all of them do, right? So a controller for just a management plane, the management plane, is okay. I think that having that single point of entry to control a large, amount of devices is okay. We certainly can understand that there's some disconnect or some trade-offs if you're using if you're centralizing all the control plane functions.
Right.
But I don't think, at least for me, I don't have a problem of having a controller that does the the management.
No, you're absolutely correct. The management makes total sense to centralize it. Totally, right? But again, this is more than a management play, right? Yeah, you can accomplish the same through a management interface, right? But that's not the point. Here, this is an intelligent control plane. As we peel the onion and go through this, we understand. For example, I'm going to mention something probably easy to understand. You guys are VMware people, NSX people. So on the switches, once you configure a VTAP, the tunnel is automatically instantiated. And you do this because you have end-to-end awareness of objects which are across the fabric. For example, I want to configure a VRF. If I have 40 switches, it takes one command in this architecture, right? So the fabric actually has some intrinsic automation aspects, which is way beyond just simply managing with one CLI or REST API or even our own GUI, this infrastructure. There's some intrinsic automation and benefit to the forwarding that we use this fabric for.
And so we'll go into some more examples when Alessandro goes through the NSX and the VMware integration. One comment on the controller. I think that from my perspective, you could call a management and automation platform a controller.
Right.
I think that where the controller makes sense is a controller that's managing multiple elements of your stack and your solution across things. So in the Ericsson example that I gave you, they use a controller. And the controller is managing the network, it's managing the rest of the stack. But to me, having a controller that's then managed by a controller doesn't make sense architecturally. And what we do is we remove that complexity from the environment. It comes down to, again, what we see is simplicity. You can deploy this in virtually a plug-and-play environment with standard networking without huge amounts of complexity and get scale.
And
Now,
maybe what would be helpful, and I don't want to completely derail you.
No worries.
What would be helpful is understanding, we talked a lot initially about how it uses standard protocols.
Correct.
In the bottom layer, the transport layer. So I would like to understand how that control plane works with those standard protocols underneath to make things easier.
So we'll talk about that when we go to the NSX, right?
Yeah.
As we look at that, because I'll go through these.
We can talk about
that'll
that.
keep us on track.
It's very simple.
Because this should go, and this will be similar in the question, right? So I'm going to emphasize this point that this fabric can be run in a single data center, focus on a pod, an application, whatever. But more importantly, and one of the key use cases of why people deploy it is we deploy geographically distributed. You can't do that with a controller-based environment. That fabric scales across multiple locations. And a significant, I don't want to say everybody, a significant majority of our deployments are about distributed data center interconnect off of this fabric.
So how do you, it doesn't concern me so much replicating that control plane information in one geographical area, but what about a LAN when you've got, or WAN when you've got higher latency, maybe lower bandwidth? How do we replicate?
It's not a very chatty control plane. The type of information you exchange is when a host comes on, you learn a host through ARP, and then you propagate this knowledge. Hey, this host connected to this switch, this port, in this part of the network. But it's not that we are blasting continuously information. It's configuration information that is shared. It's endpoint information that is shared. But other than that, it's a very silent protocol, and there are some keep alive. So this runs over, we have actually, it's deployed, we have a customer in Spain, it's deployed across Spain's 5 cities between Spain and Portugal, spanning multiple hundreds kilometers. We haven't found a limitation in terms of latency. We recommend, let's say, 40 to 80 milliseconds for sure. It's tolerable with this technology. It's not a close synchronized sort of mechanism that sort of governs the fabric. So I think it's not very chatty, and the synchronization is not that time sensitive as in a database cluster, for example, if you do replication in a storage environment. It's a lot loose and tolerant to sort of network fluctuations.
And we do other things to optimize traffic. So we eliminate ARPs and discovery by knowing in the database where workloads and endpoints are, and as they move, all of the devices know that, so it doesn't have to go and discover and learn for things. So there's a lot that we're doing within this, right? The service provider deployment that Alessandro mentioned is within that metro, right? In Europe, they're close. The other one, the end user customer, 2 in the US, pretty far distribution, and one of their sites is in Germany, and they're able to meet that requirement.
From a routing protocol perspective, maybe this makes it simpler in my mind to understand. Does every device appears to be its own endpoint?
Absolutely.
So I would have, if I have 40 devices, I have 40 BGP peers.
Yes.
Just like I would have in.
Absolutely. Yeah.
Okay.
Totally. Yes. So again.
So it's not. It doesn't appear to be one device.
No.
It's
Absolutely. It's a fully distributed. I mentioned before. It's a fully
right.
distributed data plane and control plane from a networking standpoint. And then you have this sort of, think of it as an application. It runs atop a TCP socket, effectively, right? That stitches intelligence or visibility or information across all these nodes, right? And one of the sort of a benefit, the single point of management, but like you point out, you could accomplish the same through a management station, for example, or a network management system. But here the real benefit is that this fabric, because these switches share information, it's capable now of optimizing forwarding. For example, in an environment like data center interconnect, you don't want to have ARP traffic going all over the place. But because you have knowledge of all the endpoints connected to the fabric, you can actually suppress broadcast, unicast, and multicast traffic. Right? Those are small things. The tunnel automation is another example. So there are a lot of sort of optimizations that we do in the fabric. And from a configuration standpoint, you have to configure one VRF, one VLAN, you configure it once, and then you ask the fabric to distribute with a scope qualifier, scope fabric or scope local, distribute a particular command. So there's a lot of simplification in the way you provision the fabric. We have one customer that deploys VRFs, 95% savings over the previous technology in terms of number of commands, command line interfaces, compared to the previous technology they migrated away from.
Great.
Okay, so that's, again, a little bit more than a single management plane.
Yeah, that makes a lot more sense.
Okay.
And just before we move on, I'll use this slide just to give you the context of scale, right? In being able to build out this large-scale network, and as Alessandro talked about, building the multiple domains and then connecting them together, right? But within our management platform, you're able to manage those multiple domains and be able to manage across them, right? But as you build the management, the architecture in that, you can build this out. In this particular environment, this entire network was built with one physical device type, right? With the devices we have today, they support 10, 25, 40, 50, 100 gig in the same box. So from a system sparing, consistency, operational management, one device is running this entire network.
So you're spanning through the same box.
Exactly. Same product everywhere in this entire network.
And each pod can be a fabric. And the scale is not that it's a gigantic, massive fabric. Every pod is a fabric. The spine layer is a fabric. The super spine layer is a fabric. So you manage, let's say, 8 or 10 logical devices instead of, let's say, 100 plus.
So do you treat different models of different manufacturers the same, or do you have?
Yes.
Like,
The difference would be the stipulation I would make is the capabilities that we deliver are dependent upon the hardware that you deploy.
right. But if they're all using a similar chipset,
right?
Yes.
Trident 2 based, you're going to get all of that functionality and more. And then which CPU is running in there? Can you do NFV? Can we do deeper analytics? It's driven by the hardware, right?
Yeah.
But
you
the
wouldn't care if
software,
there's an Edge core sitting next to a Dell, next to a.
Yeah.
there'd be a difference in functionality based upon the specs of the box.
Right.
But we don't care.
We don't care.
And to that question, I think this is a really important point, what you just asked. You can mix and match those boxes in your network. If you had Dell today and you wanted to add some other boxes, they can all interoperate on the same fabric running our software. It doesn't matter what the hardware is. At the same
How
time.
about code revisions? Can you run different? Is it all?
All the devices are going to be running on the same rev of the fabric.
Yes.
That's how they're going to communicate and do all those pieces. So at the architectural level, you take a traditional network, and very hard for SDN vendors, especially controller-based, to go in and say, well, sorry, push the wrong button. I can go in and just insert at the leaf. Or in the campus, which none of the SDN vendors are really addressing today, the campus environment, I can deploy at the core of the distribution, bring that fabric architecture across many locations of a campus environment, and keep my existing PoE and basic switches and Wi-Fi. The value here also starts bringing in advanced services around security and other functionality that you can't get with the legacy network environments. So we've really tried to make this simple. Sir.
Back to the campus. I mean, you guys are supporting PoE Plus and.
No, because the PoE is going to be whatever they've deployed already. Where we would play today in the campus, and I emphasize today, would be at the distribution or the core layer of the campus, interconnecting the PoE switches, right, or the Wi-Fi access points. We have different levels of integration, especially in the analytics side, so we can integrate with Aruba and see mobility and endpoint information and pull that into analytics. But today, strategically doing a PoE switch isn't in the near-term focus. It's more building that broader fabric across the entire campus. With our recent announcement with D-Link being added as an open networking partner and them having a broader portfolio, that would make sense for them to expand and be able to support that.
I was kind of curious on when it starts to get into the VoIP world, but.
Right.
But then there's some more enterprise-centric features you would.
Yeah, absolutely. You have to do
Right. 802.1x and
voice VLAN,
right.
all those things.
So sitting at the top really makes sense and allows us to scale out and focus on delivering at our core capabilities.
Yeah, absolutely.
So high-level snapshot security policy, as you get the point now, everything scales across the entire fabric, and we are able to create that consistency of policy definition because we have isolation, control plane, data plane, management plane, that gives us that value, but we're able to drive the tenantization. Whether you want to apply that tenantization at a application level segmentation, user segmentation, all of those capabilities are built in to deliver that across the fabric and defining policy. And how we manage that environment is key in policy definition. Availability, resiliency built into that network as well. Tested in very large scale environments, sub-second failover. Controller-based systems that we've seen from other companies can't deliver sub-second failover. We have no reconvergence. It's all built within that network environment. As Alessandro said, half the network could die. All you lose is those ports. The rest of it is going to keep operating. Right. I call it chassis-like resiliency because the chassis has been engineered for sub-second failover and the active-active kind of environments, which is why customers are using and deploying our environment for active-active DR, HA types of deployments in their data centers to be able to create that environment, whether doing hyper-converged or other types of data center services.
How are you guys detecting dead peers with regards to the sub-second failover?
So we use standard protocols, BFP or ECMP, everything is standard. So we operate like a regular switch detecting that a peer went down, link down, the same logic. So we rely on standard protocols. And that ensures for even overlay and underlay, when we have VTEP VXLAN, worst case reconvergence for 500 milliseconds. We say sub-second to be prudent, you never know. But in reality, we measured anywhere between 200 and 500, 400 milliseconds. In any condition of failure of a node, a link, an overlay, an underlay, it's actually, again, it operates like you would expect a network switch. It's no different.
So if you have a failure on one of the switches in the software, for example, you treat the entire switch as a failure, or you isolate the process on the switch?
Yeah, no. Again, the networking layer is one thing. So the switch keeps forwarding, BGP keeps working. We're talking about a failure at the fabric level. Let's say we're losing packets on the fabric, there's some event. So the switch in that case becomes isolated and can be evicted from the fabric. Because if it doesn't get evicted from the fabric, subsequent configuration performed on the fabric will not fall through. We have this concept of atomic transaction at the fabric level. So we use three-phase commit. If one of the nodes fails, all the other we roll back the specific command or configuration on all other nodes. So in order to, when a node fails to perform or continue working, you need to evict the node. And then the node can repair and can actually automatically inherit the configuration from the fabric.
I want to highlight this point, and for time, we're going to skip the analytics and go into the VMware, right? Because we need to be done at 3:30. But I want to highlight what he just said, because this is key to the distributed architecture. We support dynamic rollback. So you do a configuration, it doesn't work, you're going to evict a switch, you can roll the entire fabric back to the previous state, near instantaneously. You can roll it forward. You can maintain multiple configurations in that environment and change that personality.
But I mean, all that data lives on your switch?
Yes.
So management, I'll put it at a high level here, and so we have time to go through the VMware integration. We have multiple, it's API based, right? Command line for people that do command line and the NetOps guys that want to do command line, no question. Parity between command line and APIs. So you're not giving anything up if you want to do that. We have our own management platform that is called Unum, Pluribus One, Latin, kind of pluribus, play on the name, and that's providing not only automation and management, but the analytics have been built in. And if you followed the company, again, we're not going to have time today, we've integrated the analytics into that platform. I'll just give you the teaser. Let's not go down into it today. The basis for intent-based networking sits in the fact that the management, the provisioning, the policy, and the analytics are all built in the same platform, running on the same database environment. That's a key aspect of where we're going with that. Full VMware vCenter integration, which is what Alessandro is going to go through, and then the API integration and Ansible and other things that you can integrate that platform. So let's go into a little bit deeper. So again, I'm going to skip the analytics, and happy to give you guys the slides, and we'll do this in 3 weeks and talk about what we're doing at a high level. These are the areas that we're talking about here at VMworld in what we're doing as far as integration. So the underlay, which we've talked about, integrating that from a VXLAN, NSX perspective, providing the hardware accelerated VTAPs, vSAN aware capabilities for data center interconnect. And a key thing there is we do a lot of optimization around multicast deployment. All the automation integrated and driven through vCenter. And the analytics, we have the extension of our telemetry that I can put into a probe, or an agent. Agent's the wrong word, that's confusing. A probe that's running in a VMware server.